Okay, let's have a class. We will do a pole plating today, but before that, everybody have your plates. Let's look at that. Okay, I'm gonna show you something I did really good, something I didn't do very well. This is one of the plates I did good. This is 10 to the power of 3 dilution E. coli, lots of colony. This is 10 to the power of 5, lots of colony. But I did really good to 10 to the power of 7. You see a very beautiful isolated colony. So that's my best place. This set I did good. However, there's something happens. I did the second set. This is 10 to the power of 3, looks not good. This is 10 to the power of 5, looks fine, but you see the mold's already growing. And this one absolutely is horrible. That's what I did. Is that like a mycelium grows up like a, what? Fungi. So you see, I had a very good place myself, and I have a horrible one right here. That happens for the lab because it could be contaminated with the tubes, could be contaminated with the original plates. And also remember, these plates we have been put in the room temperature for about a week. And this 25 degrees Celsius is very nice temperature for fungi to grow, especially for molds. And yeast, they may need 37 degrees Celsius. So when you look at these results, it's interesting. Now let's see others. This one I did okay. 10 to the 3, fine. 10 to the 5, 10 to the 5, looks beautiful, this one. This one I did really good. And this one, not good. Some contamination. Look at those. If you see the colony is not uniform, which means contaminants somewhere. And I don't know where they come from. So I have get 2 plates really good. Okay, right here, let's see. This is the one for you guys group. That's good. 10 to the 3, we get a lots of colony. 10 to the power of 5, we did fine. 10 to the power of 7. Countable still. Okay, so I have some example here. If you guys do not have a good results, you can use mine to take a picture. Is that okay? That's good. Now, how are you going to record? The recording is usually very straightforward. Our results, 10 to the power of 3 dilution factor. This is TNTC. That means 2 numerable 2 count. Numerable 2 count. And you can even say 2 much 2 count or something. This is like 2 many 2 count. Same meaning, okay? How about 10 to the power of 5? Still TNTC. Now why we say TNTC? Because we want the plates colony should be between 30 to 300. That is, we call it an acceptable zone, and we call it a legal zone. How about 10 to the 7, the power of 7? Yes, it's countable. So, if I have only 1 plate, then I have to count. It does not matter which zone. Okay, let's do it. Count. How you count it? You need to use a Sharpie pen, and then close it at the back. Then you count like that. Okay, whenever you count, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I get 25. Well, roughly a little bit below because this is the only place we have accountable. So this is 25. So what is the population? Now here what we talk about is concentration. So the total concentration is 25 multiplied by 10 to the 7, that equals 2.5 multiplied by 10 to the 8 CFU per ml. And you can transfer this to the log. This equals roughly 8.3 log 10 CFU per ml. Okay, if you want to transfer to the log. So this is how we calculate. And you guys can do it by yourself. Look at your 10 to the power of 7 place and you can count it to record on your lab notebook. If your place looks horrible, you can borrow mine, but then please return it. And when you count, always count at the back. Not like this. Okay, not like that. Always count at the back, use a marker. This is what we have. Now some people may be not very good at math. Okay, if I get 2.5 multiplied by 10 to the 8. Okay, I want to transfer to the log 10. Okay, you know that this guy can be transferred into log 10 CFU per ml is 8. Is that right? 2.5. How do you do it?
Yeah.
Yes?
Please use a different color. It is hard to see from here.
Okay. Let's just remove it. Okay, let me show you. Some of you are not very good at math. Okay, it depends. Okay, 2.5 multiplied by 10 to the 8. Oh, of course you can use calculator. Okay, that's I don't need to teach you. How are you going to do the calculation? 10 to the 8th, you know. Is that right? Is that correct? That equals 8 CFU per ml. Now, how much is log 2.5? Okay, this is 10 x equals 2.5. This x roughly 0.31, roughly. Okay, so this is equals roughly 0.31 log 10 CFU per ml. And how are we going to transfer log at the top of here? This equals log 10 2.5 add log 10 10 to the 8. Okay? So this replaced with this replaced with that. You add up them together. This equals 8.31 log 10 CFU per ml. That is what I said. E. coli grows 35 degrees Celsius. 24 hours, roughly 8 log. If you don't know, it's okay. In my class, you can use calculator. Okay, that's a math teacher supposed to be teach you. I'm not a very good math teacher, so, but I know the story behind it. Okay, in the exam, you can just use calculator. So just want to let you know how the log comes out. And we mentioned that because bacteria is too many, and we want to do a statistics comparison. You cannot compare like 1 cell, 1,000 cell, like 10,000 cell, 1 billion cell, 1 million cell. So we have to transfer them to the log 10 because to reduce the statistics error. Okay, that's something. So the recording of your results is very easy, and you can take a picture of your results. Okay, today's work, very similar, but what's the difference? Instead of we had mended agar, we're gonna using petri dish, empty petri dish. So how are you gonna do it? Everybody do it individually. You get your E. coli. Shake. Same thing. Then you do the dilution. The same like you did the last time. Yes, 0.1 from the first one. Mix very well, shake 15 seconds, 0.1 go to the second one, shake very well, 0.1 go to the third one, shake very well. And then the dilution factor of the tube is 10 to the power of 246. Again, we are adding 0.1 onto the agar plates, so the final dilution factor is exactly the same. And don't forget to label your initial, batch number, date, and the E. coli. When you do this, finish here. After you serial dilution. Now, remind you game change tips all the time. The same thing using only one tip, add the solution here. You have to wait. Because you add 100 ml here, it's just a tiny bit of liquid. And there's no agar. Is that correct? Where's the agar? The agar has to be melted. So the agar is at the water bus. And it's very hot. Okay, so I can turn the camera a little bit. The agar is right there. Okay? We will help you, and the TA will help you. Just coming out from the autoclave. The water bus setup, 55 degrees Celsius. Very hot. Why? We want it to be melted. So make sure if you take it, use gloves. Okay? And then when you have the gloves here, we will do is we will gently pour them, which means we're going to dump it. We're going to dump it onto the agar plates. And then we gently stir it like you make a pudding. And then it will be solidified at room temperature around 5 minutes. Okay? So you see the difference when you do spread plating. This is already melted and you spread on the surface. The pour plating is you add the liquid, at the same time you add the agar, and it's melted agar. But at room temperature, it will be solidified like the pudding is solidified. Okay? But be very careful, it's very hot. Another thing, make sure your bench is clean after this. Because all these type of the agar could be solidified on your bench, then your cultivation bacteria on the bench surfaces. So make sure it's all clean and not have any sticky left. Okay? Now how many we're gonna pour there? Roughly we cover the bottom, so roughly about 20 ml, 20 milliliter. Okay, so this is what we're going to do. So, what's next we will do? The next work we will do is everybody coming to the front desk. You're gonna get you E. coli. You're gonna get you 3 plates, 3 dilution tubes, pipette guns. The first thing is label your petri dish. Where you label? At the back. Okay? And then you go ahead to do the serial dilution. Until you're here, you have your hands up saying, I'm ready to do pour plating. Then we are coming to help you. Okay? Otherwise, it's a completely mess. Now, some of you want to be interested or want to do yourself, you will come to use it. Make sure you wear gloves. Okay, you have your own glove, another glove to protect you. It's very hot. So, label, finish serial dilution, then have your hands on, say, I'm ready for pour plating. Then we are coming to help you. Okay? Very good.
Okay, so the plates from the last